So good morning, everyone. I'm Rafael Cardenas. I'm a senior software engineer at Hiro. Today I'm going to be giving you some insider info on the API, specifically if you're an NFT developer or creator. So on this talk, I'm going to go over 4 main topics. First, we're going to give a very quick overview on what the API is, in case you're not familiar with it, and how it plays into the Stacks ecosystem. We're going to go over some of the new NFT endpoints that we created. We're going to see 3 endpoints that I hope will be very useful for you. We're going to also see some performance optimizations that we've worked on the API to make it faster, make it snappier. And lastly, we're going to see some of our future plans. We have a lot of things going on, but some of the ones that I'm most excited about. So to give a very quick overview on what the API is, I'd like to start with the main goals of this system. Basically, the API is a system that indexes all the Stacks blockchain data into a Postgres database. So as you may know, Stacks nodes continuously produce blocks on the Stacks blockchain, and within these blocks are transactions and events. So every time one of these blocks or microblocks is produced, we receive it on the API, we process it, and we save it into a local Postgres database. We do this because after that, we provide easy access to this data through the use of JSON endpoints. Some of the data that you can consume are account information. For example, if you want to see balances, transaction data. We also provide block information, microblocks, smart contracts, proof of transfer status, etc. And the way that this plays into the ecosystem is that the API is fully open source. We aim to do fast releases. We are continuously pushing new code. And we also aim to make it as easy as possible for anyone in the community to deploy it on their own infrastructure. So who are our target users? Mostly, we target Stacks developers in general. So if you're a Clarity developer, NFT creator, or just somebody who's starting to learn on Stacks, you can use our API to get information about the blockchain. We also target applications that are built on Stacks. So any of the DeFi apps that you probably used, marketplaces that you've listed your NFTs on-chain analytics tools, etc. And we, of course, also target our own Hiro products. So for example, if you've ever used the Hiro wallet or the Explorer, you've used the API behind the scenes. So right now, we serve a lot of traffic. We do around 400 million requests per month served. The last 30 days, we've had an availability of 99.97%. We're aiming to get this to the 5 nines. That's a target that we have. It will be very hard, but we're working on it. But what I want to focus today is on 3 new NFT endpoints that we've created. If you're an NFT creator, we believe that these will be very useful to you, because historically the API has served the very basic data about the blockchain, such as blocks, transactions, like I just mentioned. But we want to start creating endpoints that actually give you much more process data that is actually quite difficult to get by yourself. So the first endpoint that I'm going to show you is the NFT history endpoint. As the name implies, this allows you to see all the history of the events that have been affecting one particular NFT asset. So it retrieves all the blockchain events, of course, and it is useful, for example, if you want to see the asset trade history from one NFT. For example, we're looking at some NFTs on the gallery behind us, and if you query this endpoint with any one of these NFTs, you'll see all the events that have affected through the history of the blockchain ever since it was minted. You'll see the mint, you'll see all transfers, you'll see when it was listed to marketplace, unlisted, sold, etc. You can also see the chain of custody. So all of the different addresses that have owned this NFT will appear on this endpoint. So that gives you an idea if there's an NFT that is very popular with users or owners. You can determine that by using this endpoint. And by the way, I'm showing this link if you want to learn more about this or any other endpoints that we provide on the API. You'll get to see examples, more details about the arguments, etc. But right now, I'm just going to show you one very simple example. On the top there, you're seeing the path for this endpoint. And you can actually see that we expect 2 arguments at least. The first one is the asset identifier, which is the machine name, so to speak, of the NFT collection. And the second one is the value, which actually specifies which NFT you want. This example response that I'm going to show you here is from an NFT number 2051 from the Explorer collection. This NFT has only 2 events. The first one, these are sorted in descending chronological order, so you'll see the first one on the bottom. You can see that it is a mint on the event type. So this was when this NFT was minted. You can see, for example, the transaction ID that made this mint, the recipient, which was the address that claimed this NFT. And on the next event, you'll see the transfer of this NFT from the same address that minted it into a marketplace. So right now, just by looking at this response, you can see that this NFT is currently listed on the marketplace. If you want to get more information about the transaction, you can actually add another argument to this call that will return, instead of the transaction ID, it will return the complete transaction object that contains, for example, the contract that was called, the fee that was paid, what function arguments, were used, etc. So this would allow you to see what price it was listed for, what was the ultimate price of purchase, and so on. Oh, thank you. Yeah. Some folks from marketplaces, yeah. I'm glad it is useful. Yeah, thank you. The next one is actually one that I find very useful. It's the NFT holdings endpoint. What the name implies is that for every Stacks address, you can determine which NFTs it owns at this time. So as I just mentioned, actually this works for any Stacks address or smart contract, because smart contracts can also hold NFTs. And this is very useful, for example, if you're building an application that needs NFTs for access. So let's say that you're building something that you have to own an NFT in order to gain access to that application. You can use this endpoint to determine proof of ownership of that NFT. You can actually filter by the collection that you want to look for. And obviously, it makes your job much easier. You can also use it for marketplace profiles. So for example, if you visit a marketplace, you'll see that you have your own profile from your Hiro wallet, which lists your name or Stacks address and all the NFTs you own in order for you to be able to list them on the marketplace for selling. Also, if you're building a game, you can get character item lists from this endpoint. You can also determine, for example, if you query this endpoint with a marketplace contract, you can determine which addresses are selling the most NFTs and some other very useful data. In this example, as you can see, we only need one argument, which is the principal. We call a principal a Stacks address or smart contract ID, basically an identifier of somebody on the blockchain that can own an NFT. And in this response, which is truncated, by the way, I'm showing just 2 NFTs that this address owns. The first one on the top, it's actually a BNS name. In case you weren't aware, BNS names like .btc are NFTs, actually. So that is listed here on this endpoint. And on the bottom, you can see that this address owns a Project Indigo Act 1 character. On the value key, you'll see that the value is 149, so this is number 149 from that collection. And again, you'll see the transaction ID, and optionally, you can also get the complete transaction object. Lastly, the NFT mints endpoint allows you to retrieve all the mint events from one NFT collection. So for example, if there's an NFT collection that just launched, you want to see how many of those assets have already been minted, how many are left to be minted. You can determine that with this endpoint. You can also get which address is making the most mints, for example. That would be very obvious there. You can get mint statistics like how much time did it take for the mint to run out, etc. So this endpoint is also very simple. You just need to give the collection ID. And as an example here, I'm giving the Megapont Ape Club response, which is obviously truncated. There were 2,500 total apes in this collection, and I'm just showing the last two. The one on the top, you can see that it is number 2,500, so it was the last one minted. You can see which address claimed this NFT, at which transaction ID, and so on. Next, talking about performance optimizations, I'd like to mention that in order for us to give the data that I just mentioned, we have to do a lot of computation because if you're not aware, on blockchains, you can have very different circumstances that produce, for example, duplicate data or transactions that get reorged because of if the blockchain was reorged. So on the API, we actually store massive amounts of data. And for example, in order to determine the ownership of an NFT, we have to do a lot of calculations to figure out which transaction was actually valid, which one was invalid, which NFT event it produced actually got written into the blockchain, etc. So in order for us to run those queries, we have to dedicate a lot of CPU power on the database. So one of the first optimizations that we did was we added database caching. What this means is that every time we receive a new block, we pre-calculate for all the NFTs that exist on the blockchain, who owns it right now. And this allows us to save that data into a materialized view on Postgres, and then just return data querying that view, which makes the endpoint very, very fast. We've been working with better indexing for our databases to make queries even faster. And this has really, really impacted our response times in a good way. Next, we've added chain tip cache headers. What this means basically in simple terms is that whenever we receive a block, we take the block hash and use that as the E tag on all the on all the responses that we return to users. Because obviously, the blockchain data doesn't change until we receive a next block or microblock with new transactions, right? So there's no point for us to recalculate the same response more than once if we haven't received any new information. So this actually helped a lot in the response times. We're doing caching at the CDN level, and this has made a lot of increase in our response times and performance. Lastly, we're doing faster deployments. We're working very hard on this. This is something that we're not done yet. We've added some run modes to be able to run the API with different configurations. For example, if you are only interested in running the API to query the database, you're not really interested on the endpoints, you can do that. We're also working on faster event imports, which means for every new version of the API that we put out, we have to basically give it the whole blockchain history so that it gets to a correct state with the new database schema. And we're working on making that process much faster than it is today. So glancing over some of our future plans, as I mentioned earlier, we have lots of things going on. Our GitHub backlog is completely full. We're actually hiring. If you're interested, we need help with this. But I'm going to give you a preview of 3 of the features that we're working on that I'm most excited about. The first one, actually talking about NFTs, we are starting to provide socket updates for NFTs, which means that you'll be able to subscribe to real-time events that affect one NFT asset. For example, if you're building a game that in which you want to detect when a character changes from one user to the other in a transfer, you'll be able to get this update as it happens instead of waiting for you to query our database or our API. If you're building a marketplace, you want to look at an NFT that has a bidding war going on, you'll be able to receive these events in real time. And this will be very helpful also for us to reduce some of the traffic that we have on the API and make it more efficient. Next, we're adding statistics endpoints. What this means is that we are starting to notice that the community is very interested in statistics about mempool transactions, for example. How busy is the mempool right now? Which of those transactions are actually valid? Which of those have been replaced by fee, et cetera? We're also providing endpoints that give you asset distribution on STX and on any fungible token, and some others that we think will be very helpful, especially for on-chain analytics solutions. Lastly, we're doing a lot of improvements on our open API specification. Right now we have it, and it's working, but it's not really there in terms of documentation and some of the support for generators for specific languages. Right now, we provide a client on JavaScript, but we've noticed that some of the community members write their code in some other languages like Java, PHP, Ruby, et cetera. So we want them to generate clients as they need it. And we hope that this would give us even more traffic and be able to serve more developers. So that is all I had for today. Thank you very much. If you want to learn more about us, what we do at Hiro, please sign up for the newsletter. You'll be able to do that by scanning that QR code or visit our website at hiro.so. So thank you for being here.